Thank you so much. And hello, everyone. Good afternoon. My name is Raj Bhatt, and I will be leading the first session of today's presentation. Along with me, I also have Sunil Yadav, who is going to share some best practices around how to harden the AMI before you deploy an S/4HANA solution. This is actually a 3-day event. Today, we are going to talk about how you can secure the AWS Foundation to get your SAP S/4HANA workload ready for the migration. Tomorrow, my friend and my colleague is going to demonstrate how you can architect and deploy an S/4HANA system on AWS using a tool called AWS Launch Wizard. And on the episode 3, we will be sharing how you can migrate and optimize SAP S/4HANA workload on AWS by following some best practices and recommendations from my colleague. Yeah. So what we are going to learn today, before we start building the S/4HANA solutions on AWS, we would like to cover some AWS security fundamentals, right? And how you can utilize an out-of-the-box AWS solutions to provide an ability to control those secure requirements automatically, right? And after that, Sunil is going to demonstrate how you can select an operating system from the AWS Marketplace and then harden it according to the CIS standards. And Sunil is also going to share some best practices and recommendations around how you can utilize AWS services like SSM to further operate your SAP workloads more securely. So with AWS, you control where your data is stored and who can access it and what resources your organization is consuming at any given moment. Fine-grained auditing and identity and access controls combined with continuous monitoring for near real-time security information ensures that the right resources have the right access at all times, wherever your information is stored. And you do have an ability to automatically secure tasks on AWS, and that enables you to be more secure by reducing human configuration errors and giving your team more time to focus on other work that are critical to your business. Selecting from a wide variety of deeply integrated solutions that can be combined to automate tasks in novel ways, making it easier for your security team to work closely with developer and operations team to create and deploy code faster and more securely. Now, we do govern the AWS platform by providing a higher standard for privacy and data security, and we are all vigilant about your privacy. Now, with AWS, you can build on the most secure global infrastructure, knowing you always own your data, including the ability to encrypt it, move it, and manage retention. All data flowing across the AWS global network that interconnects our data centers and regions is automatically encrypted at the physical layer before it leaves our secure facilities. And with that said, let me move to the next slide. One of the ways that we actually help our customers is to follow a roadmap, right? So SAP journey to AWS is not a one-team responsibility. Now, implementing security controls at AWS infrastructure, operating system, database, and at SAP application has usually been part of any SAP products. Whether it's a fresh SAP implementation, a data center exit, a transformation project, or even a lift and shift migration projects. Understanding your organization's security controls and aligning it to design and development practice should be included in the project plan. And here is an example on how AWS assists SAP customers to implement security controls as part of the SAP projects. A general understanding of implementing security is not only to configure monitoring tools, but also implement tools like implement controls like DR strategies, change control, incident problem management, backup recovery solutions, and also build the runbooks to prepare for the worst. Now, identifying the gaps in the security controls and understanding the risk for those gaps to your business should be at the top priority list to prepare your enterprise against a security vulnerabilities and threats like ransomware, software vulnerabilities, or even distributed denial of service attacks. Applying the above engagement model has helped several SAP on AWS customers to build their SAP on AWS security best practices and by implementing the controls by design. Now for next 1 hour, myself and Sunil is going to provide demos and how-to tutorials to tackle few of the mentioned security controls by design and leveraging the power of infrastructure as a code at scale. Right, so AWS provides several services to implement standards as well as customer-defined security control for SAP workloads. Now, going from top to the bottom of the screen, AWS CloudFormation Service enables customers to write their own infrastructure as a code in either of JSON or YAML format language. And then AWS CloudFormation also offers the ability to launch the templates using API access, even to further innovate and integrate the solutions based on your organization needs. Now, building SAP systems on AWS involves a lot of services, right? So if you start from EC2, we have 96 type of EC2 instances that you can select from to launch your SAP workload to handle the compute requirements, right? And those workloads could be, or the compute power could be memory optimized, compute optimized, or even a general purpose EC2 instances. Along with that, you also have the ability to select 5 different types of storages from a service EBS, Elastic Block Store. And also we have services like S3 who can actually retain your data based on the enterprise data retention requirements. And along with that, you have VPC, Subnets, route tables, AWS Data Provider, backend tool, Elastic File Systems, and many other services that customers can leverage for building those secure environment on AWS. Now, going through this entire list of services and automating those services using services like AWS CloudFormation could be a tedious task. And we are talking about a heavy time and development effort, not only during the initial software development lifecycle part of it, but also from the management point of view. And supporting those infrastructure as a code could be another challenge. So to simplify that requirement, and based on our customer feedback, we have launched AWS Launch Wizard for SAP service, which enables the SAP customers to configure the required AWS services according to SAP and AWS best practices and recommendation. And if customer would like, AWS Launch Wizard also configures the operating system and installs the SAP application in either standard, distributed, or high-levelity configuration. Launch Wizard supports deploying SAP NetWeaver and latest S/4HANA application on either SUSE or Red Hat operating system. Now, with a single plane of inserting all SAP configuration in AWS Console, customers can store common input values in the form of configuration files and utilize that to launch several SAP systems in a matter of hours. Now, my colleague Bidwan and Rosal are going to demo how SAP on AWS customers are leveraging this service to simplify their SAP system build process at a scale which is covered tomorrow. Now, SAP customer has access to this 45 services to tackle the most demanding security requirements to run SAP on AWS. Now, based upon how you configure these services, it can help you to identify, protect, detect, respond, and recover security incidents automatically. Now, it could be even semi-automatically or manually as well. For example, you can utilize services like identity and access management to define fine-grained security controls at AWS resource level. And then you can create custom managed key through key management service, and which is right here, which has the ability to define who as a user or as a service can manage the key and encrypt and decrypt the data, not only within that AWS environment or account, but also other AWS accounts as well. Now, you can also utilize AWS Web Application Firewall service that you can actually put it in front of ALB, which can protect SAP Web Application Servers against common attacks like SQL injection or cross-site scripting, even before the request hits the ALB. Now, a good starting point to understand this entire services and how these various services can help you or your organization to meet the security requirements would be to review the frequently asked sessions, frequently asked question sessions of the individual AWS services web pages. Now, today I'm going to cover an interesting feature of how you can utilize AWS Config Service, and that feature you may or may not be have discovered so far. So what is AWS Config Service, right? So first of all, it's a native serverless AWS service, which is actually available through the console, right? And AWS Config Service enables you to access, audit, and evaluate the configuration of your AWS resources. Now, config continuously monitors and records your AWS resource configuration and allows you to automate the evaluation of recorded configuration. Then it compares an event with what you have configured and then provides you a notification in a form of an SNS topic event, right? So it's pretty easy service to be that you can actually enable to secure your most of the regulatory requirements by design, right? Now, there are several benefits that customers have already realized by enabling AWS Config Service. And the first, which is very interesting, is continuous monitoring. You can continuously monitor and record configuration changes of AWS resources and third-party resources, or even custom resource type, such as on-premise service. Now, inventorying the AWS resources and third-party resources and configuration of AWS resources, and you can also monitor a software configuration within the EC2 instance as well. Through the continuous assessment, you can continuously audit and assess overall compliance of your AWS resource configuration. And if there is a deviation, you can trigger an SNS notifications and have a CloudWatch event whenever a resource configuration or any configuration changes deviates from the rules. In the change management piece, you can track relationship among the resources and review resource dependencies among them. Now, there is another advantage of using AWS Config Service is to have that central monitoring capabilities through a feature known as data aggregation. So if you have multiple AWS accounts that are deployed and you have multiple regions where your data is residing, you can actually utilize the data aggregation service, and you can view the compliance status across the enterprise and identify the non-compliant resources. And this is how AWS Config Service works. So once you define your rules, config will identify any change that is actually has been introduced to your AWS account, and then AWS Config will compare that change with how that change should look like through the rules that you have defined in AWS Config Service. Now, if there are any deviation in terms of the change or change of the resource, AWS Config Service will notify you through an SNS topic, right? As a matter of fact, that configuration changes that are being identified by AWS Config are normalized and the data are actually put in a consistent format, either on Amazon S3 as a service as well. And those events are also captured in Amazon CloudWatch. Now, one of the interesting topic about this is, like, you may have 50 or even 100 security controls. You can define your custom AWS config rules for monitoring those controls, but just like how deploying an SAP system without the launch wizard is going to be cumbersome, applying those security controls would be also very tedious and a more complex task. To assist our customers, we have actually enabled a service called conformance packs, which are actually part of AWS Config Service, that are bundled, that are actually offers you a bundled service, security rules that you can enable with just a few clicks within AWS Console. So what is conformance pack? Conformance packs are a collection of AWS config rules and remediation actions as a single entity. So for an example, you have a config rule which says that I want to secure my security group, making sure that it's not opened up widely. Those are not opened up widely, and it only allows a certain IP address range to have access on the SAP servers, right? So you can actually create an AWS config rule, and then you can enable that in the AWS console to have that restriction. Now, there are multiple of other rules that you can actually configure, and one of the way, of course, is to do that would be through conformance pack, which actually bundles all those secure config rules together, following certain standards of certain industry standards like CIS benchmark, right? And another benefit of using conformance packs is that those are actually immutable, so you cannot make any changes as a package once you deploy them, right? And if you have deployed those conformance packs using organization master account, individual member of those master account will not have permission to modify them. Now, again, this is only a simple template. On top of this, you can actually define your own config rules and create custom conformance packs based on your security requirement. So I'm going to walk you through a simple way of how you can actually enable conformance pack. Please feel free to follow along with me if you already are on AWS console. So the service is actually available in AWS config. So within the console, if you just type AWS config and then click on this config service, it will take you to this page. And over here, you click on conformance packs. And once you click on the conformance pack, you will see this page, where you will see a link, excuse me, which says deploy conformance pack. And then it will take you to this screen, where you will see list of all the sample templates. And in this case, it's actually for the CIS benchmark. And in that one, you will see all the CIS benchmark or best practices that you can actually select. And then you click on next button. And here you will select use sample template. And then you will select the operation best practices template that we just reviewed in the previous screen. You can name the conformance pack the way you want. In this case, I just named it as AWS-CIS-V1, and then click Next. Here's a summary of all the configuration that you have selected. So in this case, we are deploying the operational best practices template, which will configure this AWS account according to the CIS standards level 1, right? Now, this conformance pack is only going to provide the best practices for the AWS resources, but my colleague Sunil Yadav is going to demonstrate how you can implement the CIS benchmark at the operating system level as well through the services like Ec2 Builder, right? AMI Builder. Now, once you deploy the conformance pack in your AWS account, you will see this screen where it will say that the deployment of that conformance pack is actually in progress. And soon after a few minutes, you will see that that conformance pack is now deployed, and you now have the some of your AWS resources which are marked as non-compliant. Now, this is again according to the CIS Level 1 benchmarks. You are enabling that best practice for the AWS resources that you have launched in this specific AWS account. Now, when you click on that conformance pack to find out more details about which resources are not compliant, you will come to this screen. Now, here in the search button or search session, you can actually provide additional filter criteria. One of being want to list out all the non-compliant resources that are launched in this AWS account. So by this time compliance and clicking on non-compliant resource or page, you can actually now list which are all the resources that are not compliant, right? And if you want to filter down based on, say, AWS services, you can also just type the service name in case EC2, for an example. And one of the pre-configured compliant rule is to make sure that all the EBS volume that you have launched in that AWS accounts are encrypted, right? So if you have launched an EBS volume without providing any default key or custom managed key, then that resource will be marked as non-compliant, and it will appear in the screen. So, of course, there are a lot of other things that we can talk about whenever we talk about conformance pack. Now, security groups, for example, are another very good example that I provided earlier. Along with that, you have S3. So if you want to restrict the S3 access, making sure that only certain IP addresses have the access to the S3 bucket, you can actually define that in the AWS config as well. Along with that, you want to make sure that you have IAM roles which are restricted as well. So you can even create additional custom config rule and utilize a standard best practices conformance packs that can also provide you that ability. Now, I would not be going into more details, so let me switch the gear a little bit and talk about how this conformance packs can help you out in your SAP journey, right? So I just provided a few conformance pack templates, but we have almost 59 out there to satisfy various type of requirements. So for an example, if you are in the healthcare and life science industries, you do need to follow the FDA 21 CFR Part 11 requirements. We do have an operational best practices template that actually can enable those controls within your AWS accounts. If your workloads requires PCI DSS compliance, you can leverage the operational best practices that are offered by PCI DSS template. Now, again, this is just a starting point to get you going. I would strongly advise you to not enable that in your production account. Try to do that in a non-production or a POC account, because some of these conformance pack will have the ability to even perform the remediation actions automatically as well, which is actually sometimes really beneficial, but not in a non-tested environment, right? So in terms of SAP workloads, these are the list of AWS services which may be able to get benefited by enabling the conformance pack. So for an example, you have an IAM policy that you have created for the SAP EC2 instance. you want to make sure that that IAM policy doesn't have elevated actions. Very simple example is you might have an IAM role. You have created an instance profile role out of it, and you might have given a terminate EC2 instance to that specific IAM role. So if you attach that IAM role to any of the EC2 instance, you may be allowing any operating system user to terminate the EC2 instances. That specific example, you can actually control that through the conformance pack or creating your own AWS config rule. So if you end up having that IAM policy, even before creating that kind of policies, the AWS config will not allow simply terminate or delete that specific IAM role. Now, another example is a subnets. So you may want to create an AWS config rule to not allow the end users to launch an EC2 instance in a public subnet, right? So if somebody goes ahead and launches an EC2 instance, then AWS Config Service will get the notification. It will check that event with what you have configured, and it can even stop or even terminate that EC2 instance. The other example is, of course, an AMI, right? So you want to make sure that whenever an SAP user or platform team launches an EC2 instance, they're only allowed to launch through a specific AMI ID, right? Not a direct AMI that is available through Marketplace, which are not hardened, right? So you can create an AWS config rule that will allow you to select that specific AMI ID. And if somebody launches an EC2 with a different AMI ID, then AWS config will not allow it, or at least terminate that EC2 instance, right? Of course, on the storage side, you want to make sure you're encrypting your EBS, S3, and EFS service, right? So conformance packs will enable that configuration by default. So these are a few of the examples on how you can use the conformance packs to implement those security controls by design. Now, of course, we put this all things together, and once we have enabled it, we want to see what is the final product, right? So let's think about a hypothetical scenario where you have actually received an SNS notification from AWS Config Service alerting you on something happened on EC2 instance, right? So let's walk through that scenario and understand how conformance packs and AWS Config Service can help you to triage that specific event and understand what went wrong, what action AWS Config Service can do to remediate that security incident. So with that said, again, please follow me if you can. The session that we are trying to cover here is how you can actually identify a resource that went from a compliant member to a non-compliant member, and again to the compliant member, right? And you're looking for a resource timeline which provides you more auditing and analytic capabilities to understand that entire incident, right? So within the AWS Config Service, you can click on Resources. And in the Resources, you can filter by an EC2 instance, right? And then once you do that, you will see all the resource identifiers that satisfies this filter criteria, right? So in here, when you filter it by the AWS EC2 instance, here you will see all the instance IDs, and one of the instance ID is actually marked as non-compliant. So let's click on that EC2 instance to find out what went wrong. Now, once you click on that, you can see more details about that EC2 instance. You can see the instance ID. You can also see which availability zone it belongs to, what type of EC2 instance it is. And then with more details, you can also find out what happened to that EC2 instance through resource timeline. Once you click on the resource timeline, you will see that till 12/10/42, that resource was actually compliant. And at 12/11/03, something happened that caused that resource to be non-compliant. Now, you can actually expand this specific event and see what happened, which caused that resource to become non-compliant. So when you expand that specific event, you notice that somebody actually attached a public IP address to that EC2 instance. And that public IP address is actually also available here, right? And what AWS Config then noticed that, okay, then we removed that specific public IP address and the EC2 instance was actually stopped, right? So that's one example of finding out what went wrong, when that specific event occurred, what actions were performed to bring that specific resource in a compliant manner. So again, this is just an example. You can think about many other examples where the AWS Config Service can help you to implement the security controls based on your enterprise-level security requirements. So let's dive deep into another feature of the AWS Config Service, which is advanced queries. So one of the, I would say, benefit of combining most of the repeated events would be writing your own query, right? So you can actually write your own query to identify any deviation or to find out like list of AWS resources that are repeatedly being queried, right? So this is just an example. For an example, you are looking for how many EBS volumes that are unused and that are not attached to any EC2 instances. So you can actually write that specific query, save it in the advanced queries, and then utilize it for generating the reports. So let me show you how you can actually utilize a simple EC2 instance query, right? So you can, in the query editor, you write this simple query, selecting the resource ID, resource name, what tags or availability zone, and then you can put a where condition to identify what type of resource you're looking for, and you're looking for the state as well. So in this case, we are looking for all the EC2 instances that have a status of running, right? And once you execute that query, you'll have all the list of EC2 instances that are running in that AWS account. So this is, again, just an example to get you started. So I would encourage you to look into the AWS config rules and create your own custom rule by identifying your own security requirements. And then, of course, we have played here in just one AWS account, but most of the time, this controls the audit requirements, and most of the compliance requirements are usually governed in a central account, right, or central security account. Now, we can always talk about so many things, but this all topics around landing zone and building a secure VPC requires its own time. And at this moment, actually, I would like to hand it over to Sunil to carry this presentation with providing more details around how customer can use EC2 Instance Builder, EC2 Image Builder to harden the AMIs. So I would like to hand it over to Sunil now, and thanks for joining today's presentation.
So hello everyone, I'm Sunil Yadav. I'm SAP Principal Consultant and AWS Professional Services, and part of our SAP Global Specialty Practice team. And for over last 5 years, I had the opportunity to work with the multiple customers in their exciting journey to AWS. And today I'll be specifically talking about two of the services they use. One is the EC2 Image Builder, and the second one is the Session Manager. So let's get started. Okay, so about EC2 Image Builder, this service is a managed service, and it automatically lets you create your images, and basically it automates the pipeline for you without you writing any code for the automation. However, you can write some code to customize, as we're going to see in the demo following that. But it significantly reduces your effort required to create and maintain any golden images without writing or maintaining any automation. So if you're using Image Builder, you can create these pipelines through a wizard in AWS Console. And when any software updates become available or a new image available, or if your source images changes, you can trigger this pipeline again, which is going to repeat this whole process automatically for you. But you still have the control. If you don't want to run it automatically, you can still do it manually. Or you can have some other, like scheduling, like for example, every month, every quarter, or when some other image available, as I mentioned before. So with this EC2 Image Builder, it also comes with a lot of built-in automation for validation, which basically make sure that you can deploy some very high quality images to your production. And those validations include our standard components, and you can also add your own specific validation. Let's say in case you are adding your own custom software there. So the approach we are taking there, like with all these automations and consistency, this also allows you to make sure that you're maintaining a consistent security and throughout this build process. And in case you have to meet your internal security criteria and document and make the logs available for auditing, it provides that functionality as well. So you can actually connect to multiple other services while you're building these images. So you can leverage, let's say, some files from S3, or you can put the logs out back. And if you're especially looking for some predefined security standards like Security Technical Implementation Guide, STIG, very common with the like Department of Defense, what they are using. If you want to leverage those standards, they're all coming out of the box, and we're gonna see like how you can select those as well. Then the next part is that it also simplifies sharing of your images across AWS accounts, and not just accounts. Like you can actually specify which region and which accounts you want to distribute. So like when you start your journey, you might think of having like a simple account structure. But normally for the enhanced security, if you're going through our landing zone service or control tower service, that gives you a structured layer of different accounts. And normally you deploy this EC2 Image Builder in your like shared services account or some other account dedicated for your CI/CD pipelines or automations. So from there, once these images are built, you can decide where you want to distribute. So let's say from there you can distribute it to your other accounts like Dev, QA, production, SAP accounts. And then you can also control who's allowed to launch these AMIs. And finally, the same workflow and the same approach, it works for both the virtual machine images and also for container images. So in case you are using containers for some other, say, non-SAP applications, you can use a very similar approach where you go and build your very baseline image, which could be for SAP and non-SAP both. And then on top of it, you can execute some additional steps which are more SAP specific. Okay. So this is the flow we just talked about briefly, but normally in EC2 Manager, EC2 Image Builder, you're going to start with a source image. And so one key requirement for this source image is that it must have an Systems Manager SSM agent installed. So we're going to talk about Systems Manager in a little bit after this one. But this is also our managed service, which allows you to automate a lot of things on your operations, backups, and anything you want to run on the operating system side. So, but the key requirement there is the SSM agent has to be there as part of that image. And I'm gonna show you how you can overcome that limitation, because like let's say if you're using Red Hat for SAP image from the marketplace, it doesn't come pre-installed. It comes with bare minimal things you need. So you can actually add that agent as a part of your build process. So basically the first step is to pick that image, source image, which you want to customize. And the next step is you're gonna add your like your customized software. Let's say if you have some security packages or any additional packages which are not part of the base image, you can add those here. And once you have that custom software added, like those agents or your own packages, you can go to the next step, which is the build phase. And actually, this adding the package software is also part of the build phase. And this is where you can use our your own custom templates or the templates provided by the AWS. So there are some standard, as I mentioned about the stick component before. Those are available natively as part of this EC2 Image Builder. So you can just pick it up from there. And other things could be, let's say, if you want to install AWS CLI, so you can just go and pick that component. You don't have to write any code or customize that one, because that's a very predefined setup there. Then once you're done with your build phase, you go to the test phase, and of course you want to make sure that whatever you're building, it's validated and it's compliant, because as things change in future, like new images come in, so the same thing may not work. So you don't want to distribute any images which are not validated. So you go and validate those images. And the last part is to distribute. So this is where you can select to which other regions, which accounts it can go. And if it is like, if you need the same images in the same account, then you don't have to do anything. You just pick the default setting, and it just makes the image available in that same account. Now, so Raj explained about the CIS level 1 benchmarks and how you can achieve it using the AWS config and conformance packs for the AWS infrastructure and services. But the one part we did not cover there was like how you make sure that the same CIS level 1 benchmark is met for your operating system as well. So that part we're gonna and with this example, I'm gonna show you how you can actually automate that. And of course, you can, this is a predefined standard, so you can get most of these scripts ready. And it's available publicly as well in some Git repositories, or you can write your own. But you can also go and add and customize that. If you don't want specific items which don't work with your application, you can disable those. So in this case, we're going to use a custom script. And just to give an example of how this CIS level 1 benchmark, all this looks like. So on the left hand side, you can see here I have these different numbers, like 1.1 section for file system configuration, and then you go further deep into that 1.1.1. And so they basically define what is that particular check or compliance is. And then this is like a big list of items. It goes all the way up to like 6.2.20. So I'm just showing you the end page of it. So it is pretty long. And this guide itself, from where I took this snapshot, you can see it's like more than 400 pages. But I'm going to give you like a little bit taste of what it looks like. So let's pull up the very first control. So you can see, right? So it shows right at the top the which control we are referring to. And then the important part is the profile adaptability. So it says CIS level 1. So it means that if you are trying to meet the level 1 benchmark, you must implement that. It is a requirement, right? So similarly, on the right hand side, you can see like 1.1.12. It says level 2. So if you are implementing only up to a level 1, this is optional. You can skip that one. But if you are doing level 2, then you must meet 1 and 2 both. So the first thing is like the audit part. Audit part is basically how do you check whether your system meets that requirement or not. So let's say you build the automation, and then you still want to validate that, okay, is it meeting existing images, meeting the requirement or not? Existing servers, whatever you're running, are they still meet the requirement? You're going to use the commands from the audit. And these commands tell you, they don't change anything. They just tell you the current status and then what is the expected outcome, right? And then on the right hand side, you can see there's a remediation part. So this is like if you put some flag saying that, okay, I don't want to just check, but I also want to fix it. If something is found, then you can use the code for the remediation as well. And this is all documented in CIS. If you go to the CIS benchmarks, you can find all that information. This is an example of how the same controls we just saw on the previous slide, how they're implemented. And this is a very simple bash script. So you can see it's very well documented, just to for a new, anyone who's coming across this one, for them to know what we are checking, how we are checking, which control it is referring to. So the numbers match exactly to what was in the definition of those controls. And then again, I'm just showing the start and end of the script. So again, it's like more than 600 lines of code there. So it's pretty small compared to that. We have kind of implemented all the level 1 going through those 400 pages of that guide. Okay, now we're gonna dive a bit deeper into like how to work through the EC2 Image Builder. So you can go to our console, search for EC2 Image Builder, and then you come across this particular screen here. Now in this one, the left hand side at the top, you can see like image pipelines. So if you click on that, it's going to start a wizard. But in the wizard, it's going to say, okay, basically you're customizing it, right? So for your requirements. So it might say, okay, so if you're just selecting all AWS provided components, you can just start the wizard, select whatever you need, and you can just finish. Nothing additional required. But let's say if you want to add your own custom checks or custom build components, like what we're going to do here in the CIS level 1 benchmark, you're going to add your own component there. So for that, we need to create that component first. So we're going to create this component, and it's very simple. You can just go through this template, and it says, okay, it's for the build phase. So that's the very first thing we do, the name and the build phase. And then you can see the name, and you can pick any name there which meets this requirement, and then the action. So we are saying it's an execute bash. So that's why it's a bash script we are trying to execute. Now, where is that script? So we don't want to hardcode the script in the image, because then you can't modify without launching an instance, and you don't want to do that again and again. So it could be at your central repository, it could be in your Git or some other place. And for our purposes, we just use a very simple mechanism where we are just pulling a script from the S3 bucket. So in future, if you want to make comment out something or delete something or make changes, you can directly go and do it there as well. So in this case, we are downloading an S3 file from an S3, and then we are just executing it. So that's our component for CIS level benchmark. It's the same script we just saw. Okay, now the other question the wizard is going to ask you. So we're kind of answering some of the questions which might be in the wizard. So it's going to ask you, okay, where you want to execute this pipeline. So there's a very simple option there which says use default settings, which is just going to execute in your default VPC and pick up any all the defaults. But if you want to customize that, then you can create your infrastructure configuration. So that's what we have created. So in this infrastructure configuration, you can go and you can see what we have selected. So we have selected like a VPC. So all these orange ones. So VPC. We selected a security group. We selected a key pair you're going to use for that instance. This is an EC2 key pair. You can also define which instance type you want to use. So like again, you don't want to use like a T2 micro or something if you want your images to be fast, and it also varies depending upon how much work is being done during the image build process, right? So if there's something I'll say more CPU intensive kind of stuff, then you can add an higher level instance like C5 large or something in between, right? So you can pick an instance type. That's the point here. And then you can also select your VPC subnet that we already talked. So let's go to the next one. So that is pretty much defining your the infrastructure. The other thing which is here is this is I'm sorry, this is actually the recipe. We're going to talk about these components again, but this is actually the recipe. So in the recipe, this is what executes at the start. So but at the start means like when the EC2 instance launches, and then it's going to execute this part. So the first part is the user data part here. So the user data, you can, like as I mentioned, right, the SSM agent we're talking about. So this image doesn't have the SSM agent. So what I have in the user data code is the actual code to install SSM agent right at the start. And then it will be installed before any other steps are executed. And then when you go in the recipe, like where you can select the components, so you can select some existing components. You can see the screen at the bottom that there are two components like AWS CLI, and then there's another one like simple boot test for Linux. So the first component is for our build phase provided by Amazon. And then we added our custom component. This is the component we built in previous, just before starting this recipe. We created a component, right, for our the one we are downloading the S3 file. So that particular component. So you can have just pre-select that component, which is already there. And the third one we added to have the build the testing piece. And we're going to see this in a bit more detail. Okay, so here again you can see like when you choose start the pipeline, you can choose your recipe, like which recipe we have created. And in that you can see like the same thing is popping up here again, the recipe we just created. And then here you can see in the component section. So there are two build components down here. So it basically, let me turn on the pointer. It will be much easier. Okay, so this is the part I'm referring to, the component. So that there are two build components, AWS CLI, we can install that, and then the CIS level 1 benchmark, which we just created using that bash script. And then for the testing, we're providing another component, simple boot test. So this could be a many like more complicated test where you're actually running the same CIS level benchmark script, but in a like a audit mode, where you're actually seeing if all those are in place or not. But at a minimum, you want to make sure that whatever image you're building, it's bootable, that the server comes up or not. So we did this one here. And then other things, I mean, you can go to the next one. So I'll show you that. Yeah. So yeah, so this is the infrastructure screen which comes later on this. So we already created an infrastructure where we define the VPC. So you can select that existing configuration, SAP CIS infrastructure configuration, and then or you can, if you want to create your own, then you can even select this create distribution settings using default. That is for the next phase. After the infrastructure, you can select the distribution settings. In this case, we're just distributing to a specific region, US East 1. And then it won't be shared with any other account. It will be available only in that particular account. Okay. Now that our image has created, you have, so when you're creating this pipeline, so not the image, when you're creating the pipeline, it's going to ask you about, you want to execute it automatically at a predefined schedule, or through some, you can even execute it through some other, events, or you can actually have it manually run. Or so this manual option will always be there. So let's say if you want to build some ad hoc image, like right now, for example, you can select that pipeline, go to actions, and click on run pipeline. So once this pipeline starts running, like after a few minutes, normally it will come to the status. So you can see the status as building. So once it is reaching to this build status, so behind the scenes, it's leveraging the systems manager. And that's why there was a requirement to have the SSM agent running on that particular image, part of that image. And this basically kicks off an whole SSM automation. So after, if you want to see what's happening inside that, if you're still curious, then you can go to the systems manager, and then you can go and click on this image here. So this is the execution ID here, and then this will actually take you to further details. So you can see there are multiple steps being executed, and it shows you the overall status and how many steps have been executed or how many have succeeded. And once this completes, it's going to run for I think this particular one had about 26 steps total. It could have many more steps which may be skipped, but what you need to look for is this overall status as success. So once this is done, then this build one is completed, and you can see the step 21, right? Create image. So it creates the image, verifies, and then it completes that one. But now then it's going to kick off another one. This is for the testing phase. So you can see the builder image test image document. This was the build image document. So now the same thing. You can go and check the details of that and look for the overall status to be successful, which will tell that, okay, this has completed. And then finally, you can come back to your pipeline, and you can see the status is now available on the output images section here. And then if you go further into that images, you can actually see the image ID, which it has created through this pipeline. And then if you can go to these other tabs like distribution configuration, distribution settings, which is the same thing which we looked earlier. And if you go back to your EC2 images in your EC2 service, there also you can see this newly created image now. And now from this part, you can actually launch another EC2 instance or leverage it through EC2 Launch Wizard. That's what you're going to see tomorrow. That how we can use Launch Wizard not to just pick up some standard images from Marketplace, but also your own custom images. And this is how many of the customers do. They don't just use, unless it is a kind of a very POC or test. Normally they harden those images before they use it for production environment. So now we'll talk a little bit about Systems Manager, and then we'll go to the Session Manager, which is again a specific feature inside Systems Manager. So Systems Manager actually provides you the, it's a managed service, and it provides you out-of-the-box support for a lot of automation and monitoring for your infrastructure and operations. And it can, I mean, most of these things you can build on your own, but then if you use this Session Manager, it can significantly reduce that time. And like as I mentioned, right? So you can have, we have many like more than 60 SSM documents which are predefined for you. Like for example, if you want to create an image, if you want to delete a snapshot, or if you want to install backend agent on your HANA instances, all those documents are already available for you. And you can combine those documents and add your own some custom documents and create like some interesting automations. The Systems Manager you can also use to manage your hybrid environments. It's not just AWS. You can actually add some servers from your on-prem, or even run commands and scripts over there. So you can have like a very central view of all of your inventory. And then it also helps you maintain your security and compliance because these automations can keep things like standard. Okay, so here we're gonna see like a lot of features of Systems Manager, and I'm gonna point out some of. We're not gonna go through all of these. This topic has been covered like in pretty much detail in previous reinvents, and you can easily find most of this information in our previous recordings. But I'm gonna highlight few things from this particular group that you can leverage this parameter store, and I see many customers using it frequently. They can use it to store some sensitive information, like let's say in your automation you want to refer to the your some passwords to be used, or some master password for your installation. You want to use it only for installation, but you don't want to provide that password like every time. You can store it here. Similarly, if you have some other like SAP specific configurations, like your SAP sys group, which remains constant like throughout your SAP installations. Similarly, SAP INST group ID. So those things can be managed from here. And then you can look at the third section here, the change management. This is where you can define your change control, maintenance windows, so that in all the automations you're building, like patching or like start and stop of systems, all that is done only during those specific maintenance windows. And there's like a very complex workflow there. If you want to integrate your approval mechanisms, all that can be done. And on the node management, we have like again many features like inventory management. Run command is pretty useful. Using that, you can execute some commands on multiple hosts at a time. Let's say if you have 50 servers, you want to execute that. Okay, let me check my kernel version of SAP. You can actually run a single command, get the output from all at one click, like one run. Patch manager is there for patching. We're going to talk more about the session manager in the coming slides. So let's go there. So one challenge we heard from many customers was that their SSH it's required for most of the admin tasks, like basis admin need to go to the server, even their infrastructure and OS team, they need to manage some servers. So they use like some kind of Bastion host to get to that. But with Session Manager, it provides you like a one-click secure access to instances without the need to open any inbound port. So you don't even have to open your port 22, which is like crucial if you're using your SSH. You need to use like put your some client and connect to port 22, but it has to be open. But what if you don't want to even expose that one? Then you can use this one. And it also provides you like a centralized access to multiple instances through like a same mechanism. So it's not that you have to keep going and adding multiple servers to your like clients and profiles every time those are built. No, you just get access to the AWS console. There we can define some permissions, and then we can still control who can access what and with what user and to what level. So although those granular controls are still there, we're going to see some parameters for that. But the point is, it allows you to centrally manage all that access. So all you need to care about is like how users authenticate to AWS console and what permissions they have in the AWS console. And then finally, it keeps track of all the commands the users are executing, so which makes the auditing like pretty easy. You can run some queries using Athena. On top of that, you can store in S3 bucket those logs, and you can also store in the CloudWatch. So here's like a quick high-level like workflow of how session manager works. So user normally gets authenticated first through their single sign-on or some other mechanism to the AWS console, and then they have the permissions defined by their IAM roles, and from there they connect to the session manager service. Now, what's different here is that you don't directly connect to the EC2 instance. Instead, you interact with the session manager service, and it kind of emulates or simulates your SSH session. So it will look and feel like an SSH session, but nothing is actually going into the server. So the SSM agent which is running there, it continuously polls our systems manager service. And let's say if you run a command, okay, df -h, right? So now you're expecting that, okay, I want to see the file systems there. So that command is there, and then session manager, this SSM agent pulls that command, executes it, whatever the output it does, sends it back to the session manager, and that's what you see on your screen. And it's a very low latency process. It's not that you're gonna wait for these things to happen. So it's a very interactive, I'll say, and it happens mostly like in very close to real time. So normally humans don't see that big lag, even though it's going through multiple hops, like to session manager, systems manager, and then to the OS coming back. So yeah, the packets are traveling a bit more than what you would expect, but it's still very seamless. Now, this is an example we talked about, right? So without session manager, if you want to what's not a good practice is to just open your servers to your whole network. Like whether someone needs access or not, you just open port 22 to the whole 10 dot network or some other network you have. Instead, many customers are already taking initial steps to control that access, where they go through, they set up some bastion hosts, and they only allow access from those bastion hosts. So with session manager now, you just kind of cross out this whole block from here. So from here you just connect through session manager, and then they connect directly to those servers. So now you don't need to maintain that additional bastion host or additional infrastructure which you have to keep secure and patch. All those complexities are gone. Now, how we can just have some quick view on like how it works. So you have an SSM agent running on the operating system, and it runs on so there's like a sudo access. So it kind of assumes you can control it, and you can put it like non-privileged user as well, but by default it assumes, and it could run as it could execute commands as root as well. So that's why you need some permissions in sudo's files in Linux, and it's that user SSM-user is added to the administrators group in the Windows side. So this session manager works for both Windows and Linux. And on the Windows side, it's not going to give you that GUI which you typically see through Windows, and the desktop RDP session, but it's going to connect you to a PowerShell. So on Linux, it connects you to your shell, and then on the Windows PowerShell. So you'll still be able to execute commands in the Windows server. And then there are some IAM users and roles which invoke the session from the browser, and then the guest basically assumes that particular user which is defined. Of course, you can change that one, but all the commands are actually, like when they reach to the operating system, the SSM user is still there, and then it executes on behalf of the user. Okay, so this is just an example of the group membership on first on Windows and now on Linux. Now, how you can restrict the access to this particular session. So in Windows, it's pretty easy. You can just go and change a different group membership. If you are creating like a less privileged group, then you can just add it there so that it won't execute anything as more privileged user. On Linux side, you have two options. The first option is you can tag each IAM user or the role they are using to connect to a specific OS level user. So let's say the basis team or your OS team has their own users, and that's what we recommend actually, to have their own users at the operating system, and then just map that user to that particular user through some use of our tags. So that way, when they connect to SSM session manager, they're gonna see like they'll be connecting as only that user, and from that point onwards, you can give them sudo access to switch to SID-ADM user or the root or any other user. The other option is, let's say if you're running this SSM user as a non-privileged user, and you have some other monitoring kind of users, or who anyways you want to keep it like very simple and consistent, you can actually set a different default TOS user for all IAM users as well. So that's optional. Now this is like where you actually set it. So you go to the systems manager, session manager, and preferences, and this is where you can set this setting, the second setting, like which is unable to run as a different user. And then this is the first option. So where you go and create a tag for each of those IAM users or their specific roles on which user they can connect as. So we again, like a summary of the steps we did. So you can register your instances with Systems Manager, which is done by like installing the SSM agent there. Then you create like an IAM user or role which has permissions for Session Manager, which is the second step. Then you go and establish a session through a browser or through the CLI option is also available. It requires like a plugin, but you can connect to both Linux and Windows through that. Your session history, which is again stored in Session Manager, so you can review that, like when you connected to how you connected there. And then it also stores your output into S3, which you can also put in the CloudWatch log groups as well. Then you have the alerting mechanisms using SNS, and you can have some metrics, and you can have some alerts sent. For example, if someone is switching to root, you can have some alerts sent there. You can have that kind of functionality as well. And then you can also see the full transcript of all the commands they have executed. This is the option to connect through Session Manager in Systems Manager. So you go to Systems Manager service and then select Session Manager, and then you start the session. Similarly, if you want to connect through the Ec2 console, this is the Session Manager starting. But if you want to start with the Ec2 console, this is another option. So you go to the Ec2 instances, select the instance you want to connect, and then you can just click on the connect part. But the outcome is still the same. So you can also use like CLI, as I mentioned earlier, from your local workstation. It just requires an additional plugin. So if you already have AWS CLI installed, you can install the Session Manager plugin for that. And then this is the command you can use: start session, target, and put your instance ID there. It's going to connect to that. We talked about like it works for both Linux and Windows. And then you can have the full auditable records available for later. This is just the some of the same screenshots of how you can to see those sessions and logs and instances. Now this is the setting like we talked earlier about, that where you could store your logs. So you can pick like the S3 bucket name where you want to store those, and it's going to store like a copy of logs there. And then it could also be at the CloudWatch. So the second option you can see is for the CloudWatch. So you can specify which group they should go to. And what we recommend is that you send all these logs to your central log repositories or like some other central logging account, which is basically a read-only account where no one could make any changes, and all these logs will be available. Otherwise, it's very difficult to trust the logs if if you're putting in the same account where the same person has access to even go and delete logs. So normally that's not a good practice. So you need to you can manage that as well. So these are the same, like what kind of logs you see, right? In the like when you look at the transcript, it's going to show you like to which instance you created, and all other details specific to that that session. And then you can also put like a lifecycle policy in S3. So let's say if your logs are accumulating and you want to keep it for whatever requirement, let's say keep it for 10 years. Then instead of keeping it in S3 for 10 years, you can just after a month you can move it to Glacier, and then you can have another policy to have it deleted from there after 10 years. And these are like very lightweight, so they do not consume like a lot of space. Now, if you have your other, like by default, the session data which you are having, this is encrypted with TLS, and then you can actually use KMS as well for that. So you can just go and select the same preferences, which key you want to use. Now, there are some use cases we came across where the session manager, the customer normally for the when I say SSM agent is running, it requires an HTTP access to on port 4432 our systems manager service, and we have this public endpoints available. But let's say if you don't want to have any even outbound internet access from your servers, you can make it 100% private through our Vpc endpoints. So for that, you need to enable like three endpoints: SSM, EC2 messages, and EC2. And especially for session manager, you also need to add an endpoint for SSM messages. So once we have these endpoints available in that account, then you can communicate to the service privately from within your VPC. Okay, so that that concludes our session manager and EC2 manager topics. Now, in the coming days, we'll have episode 2 and 3. So tomorrow you're going to learn more about the different architecture patterns for SAP on AWS, and this will be followed by the various instance types you can use, sizes you can use, and how you can automate your whole configuration and deployment using Launch Wizard. So very similar to what Raj mentioned earlier. And then on Wednesday, we'll have another session where you're going to actually see how you can migrate and optimize S/4HANA on AWS. So you'll actually see the different patterns you'll have for migration, and then how you plan for that migration and what tools you can use. So that's all I wanted to share today, and we'll be now open for any Q&A, myself and Raj. So thank you, everyone.